So today we're going to look at digital switching. Digital switching is not something that's all that new to the marine environment, but if you've got a boat of my generation, you'll notice that we have a traditional switch panel with actual physical switches that you switch on and off. Most of the newer boats now have moved to this idea of digital switching because it removes all of that switching infrastructure from the boat itself, and most of them don't even have a nav table these days, so there's no real space to accommodate that. You can retrofit digital switching to a lot of boats, and most of it, like the one shown on the screen here, is NMEA 2000. So you can control it from your chart plotter or any other display that's kind of networked. What I'm going to show you here is how to do that on the cheap with a Raspberry Pi. Now there's different ways that you can do this. So I'm using Node-RED to create a path, and then I'm using KIP to actually do the physical switching. You can turn anything on and off on the boat, and you can also do that remotely if your boat is networked. There's a couple of things to consider. On the bought products, they always have a backup. So they always have a way of you being able to turn that device on and off if your MFD or however you were switching it, your digital panel, was to stop working. So you need to consider where you put these in your boat and then make sure that you can actually get to them. The other consideration with the Raspberry Pi is that it actually can't do the switching. It needs like a relay or another board to do that for you. I would also just suggest that you have another means of turning the device that you want to on and off, or you use it for less important things like interior lights, which mine is going to be used for. So I'll show you a couple of different examples, and then we'll go through how we're going to do it using the Raspberry Pi, which is a lot cheaper than buying the marine equivalent. So as you can see here, this is the switch control from Yacht Device. And this is an NMEA 2000 device. So you plug your NMEA 2000 connector into the device, and then it's able to bring that up on your MFD screen, and you're able to switch 4 different things on and off. You can see the channels on the bottom of the picture. If you take that one step further, like the Ray Marine example here, with a full glass display, there are no switches at all, and they're controlling many of their functions on their boat using the MFD. And that's really nice. It modernises everything, and it makes it look really quite smart. If you want to do that on the cheap though, how do you go about it? Well, there are a few different options. If you have a look for relay boards, you'll see that there's different relay boards, like this one here for £17, and this fits on the very small Raspberry Pi Zero. It has the same 4 controls that the switch panel we just saw from Yacht Devices has, and it's able to switch loads of 2 amps up to 24 volts. Now that's not a lot. That could control some lights, but nothing more. Now there are much bigger units, and you could also make your own if you really wanted to. This device here, this industrial model, again powered by a Raspberry Pico, so they're very small Raspberry Pis, this device is able to switch 10 amps at 250 volts or 10 amps at 30 volts DC. So it's got a couple of different options, and it's able to switch 8 different devices on and off, independent devices. So it's got 8 different relays built into it, and each one of those relays is able to deal with 10 amps at 250 volts AC or 10 amps at 30 volts DC. So it could switch on pumps, it could switch the TV on, the fridge, lights, whatever you want really with that one. And it's a bit more ruggedized, so you could do something with that, and you could mount it somewhere where it's maybe not as well protected. It's got a nice cover to it and everything else, and that's about £20. You do have to buy a Raspberry Pi with that, a small Raspberry Pi Zero, which are around £5 to £8. So there are many different ways of doing it. I'm going to show you an option now on the Raspberry Pi, because you can also use the GPIO pins on the Raspberry Pi to do this. And as I say, mine's just going to turn off and on an LED. But you can then drive something else with that. So I'll show you how we set that up next. So if we head over to Node-RED, I've got this little setup here, and basically this is my digital switching. So on startup, I've created this device here, which does a trigger. So it just sends out a trigger to activate the path. And the reason I want to activate the path is because I want to see the state of the switch. Now there might be different ways to do this, and again I would really appreciate some feedback on Node-RED because I'm learning as I go. But this way allows you to create that path so you can monitor where your switch is, and it's also going to update it when you activate the switch. So on startup it sends a message topic of digital.switch.1, so that's what we're going to see as the path value. and it just sends that out to the output. That's all that's doing. So this one just sends the SignalK value straight out. At the bottom, we're using something called the put handler. Now, I've not really come across this before, but if you scroll down in the list of SignalK nodes, you can take the values here. You've got a send put and a put handler. So this time we're using the put handler. So we've configured the put handler with the same path. So this is digital.switch.1 because we've got one and we're calling them digital switching. So digital switch.1. And what I'm going to do with that then is I'm just going to send it out to a pin, to a GPIO pin on here, and I've initialized that pin and set it to 0. So what that means is when the SignalK starts up, I could have that device on or off, but I want it off. I don't want it to come on without me clicking it. So I'm going to initialize that pin low, so it's 0, so it's off. And you can see it's just connected to it. It's also connected up here to the SignalK send path value, and the reason it's connected to that is so that we can update that to say it's gone to on or to off. So when that starts up, what actually happens? So as you can see here now, SignalK is fired up and it has gone to digital switch.1 and it's currently in the off state. So what I can do now is I can change that. So if I head over to KIP and I just unlock KIP for a second, you can use the Boolean control panel. So in here, you can set this up so that you've got either, as you can see at the top here, I've got an LED that's actually replicating what this physical LED is doing. And I've also got a switch at the bottom. So if I toggle the switch, my LED actually comes on and it's just out of shot. So I'll just record that. And you can see also the indication is turned on, so I know that it has turned on. So that could be the anchor light, for example. And then when I switch it off, it switches off. So if I replicate that, let's turn it back on. Go to SignalK, you can see the values change to 1. That's absolutely fine, that's what we expected. And if you turn it off, it goes back off again. And it's as simple as that. So all that is doing in the background is it's turning the Raspberry Pi pin. Let me trigger it again for you. So you can see it happening here. You can see 1 and 1. So it's triggering that pin to go high. So that's now sending out 3.3 volts basically out of that pin. So that could be used to drive a relay. So if I attached a relay to that, that could be used to drive that relay and turn that relay on. And that relay could then in turn power a more high-powered device. So a bilge pump, a larger light, your fridge, your TV, the radio, anything, whatever you want. And you can just replicate and copy this. And as per normal, I'll put the code online, but this is actually one of the examples that's given. It's really quite powerful because not only can you trigger things, you can get things to be triggered as well. So as you develop this further, you can do other things with it and it can be used for alerting. So let's say that bilge pump went off. You could use something similar to this to get the value back to say that the bilge pump's gone off. And I'll go into that in the future, but just for now, we're just going to use it for switching. So why am I actually doing this? Why have I started to do this? Well, I recently put some LEDs on the boat. So rather than attaching them to another switch on the boat because they're not crucial for anything, I thought I'd use the Raspberry Pi to trigger them. And then I can trigger this from my phone or from the screen that's on the boat and turn them on and off. And I just thought it'd be nice to use them. So that's why I've had a bit of a go with it. So in essence, you create a very simple Node-RED sketch like that, and you get a SignalK path, and you create a couple of buttons, and I'll show you the button config because it's really, really simple. So I've just added it, give it a name, created it as a toggle. You can have a push button if you want. The only thing with the push button that I've noticed is when you press it, it stays on. So you'd have to do a little bit more Node-RED config to revert it back, but with the toggle, it goes off again. So there it is, self digital switch 1, and that's basically it. As soon as you toggle the switch, the LED goes on and off. And you also get the light status as well, so that you can see that it's actually happened. Okay, so what I'm going to do first is I'm going to cover the switching side of this because the LED part of it is taking a little bit of a turn, so we'll come back onto that shortly. If you're interested in just the LED section, then jump around in the video. There's chapter marks at the bottom, so just jump to that section. But if you're actually interested more in the digital switching side, then just stick around for this little bit. So this is my little module that's turned up. I'm just going to run through a couple of features on this. There's obviously loads of these online, and probably I would pick a different one next time, and we'll come on to why that is shortly. But this is the module. So So as you can see, it's a 2 relay module here. If we look at it that way, we can see the outputs. So we can see the relay where it's normally open and normally closed. Hopefully that picks up on the camera. And then on this side of the relay, we've got some control circuitry. So as you can see here, there's some pins on this side and there's a couple of pins here. So how this works is we power it. We have to first of all power the circuit board this side. So you can see a VCC and a ground. So from the ground pin, we would connect that to the ground pin on the Raspberry Pi. We would connect 3.3 volts from the Raspberry Pi to the control pin, circuit control pin power here, which will power this side of the circuitry so that it will actually do something. And then we've got 2 other pins in the middle here and here. So those 2 pins actually turn relay 1 and relay 2 on and off, and we'll connect it up in a second and show you how that works. As you can see on this side, there's a little jumper here. Now if we look on the relays, hopefully that's clear enough, they actually say SRD 05 VDC, so these are 5 volt relays. Now most of the pins on the Raspberry Pi are 3.3 volts, the GPIO ones definitely, so this side of the circuitry is working on 3.3 volts and this side's working on 5. Obviously this board is designed to be used on many different ones, so not just Raspberry Pis, it could be Arduinos, it could be anything. So you're going to see this a little bit where you might have a different voltage relay to the control circuitry, and I've not actually tried putting 5 volts through that side, I'm sticking with 3. But you could also change these relays for 3 volt ones or look for one that is specifically designed for that. So what is this bit for? So well, we actually need to power these with 5 volts, so we need to take that pin off so that the power from this side isn't being transferred to the relay this side. It does actually work on 3.3 volts, but they're 5 volt ones, so we should power them with 5 volts. So we remove that pin and we connect 5 volts to this pin on the end, and that will ensure that the relays are powered properly, but the control circuit is powered on 3.3 volts. So what we'll do next is we'll connect this up and show you exactly where these go, and I'll pick some pins on there, and then we'll look at the node red setup and we'll just click them so that you can hear them clicking. And as I say, you could use this to turn something on and off, such as the radio or the TV or whatever it is, but I maybe wouldn't use it on really high powered or really critical infrastructure on your boat. Also, it would be, you can see someone's had a bit of a pop at it there in terms of the soldering, but also I'd be looking at the size of the contacts, and I don't know whether that's getting picked up on the camera, but these are pretty chunky, but obviously all of that current is going from these small terminals on the end here to your relays and then back out, so it's got to go through all of this. So if you are going to be powering high-powered devices, these are the things you want to look at when you're purchasing this. I obviously just purchased this to do the demonstration, and I might use it for something because it's perfectly fine, but it's not the best. That's kind of all I'm saying. It was really, really cheap, and as I say, it's just basically to show the demonstration of how we would turn something on and off, because the LED side of this has gone down a bit of a rabbit hole, and we'll discuss that a little bit later on about how we sort of control those LEDs now, because the plan has changed slightly. So let's connect this up to the Raspberry Pi next, and let's click some of these relays. Okay, you're going to have to excuse some of my wires because I'm waiting for some new ones to arrive and they haven't arrived yet, so do excuse those a little bit. So first one is a ground pin, so we're going to pick a ground pin here, and we're going to connect that up to the ground on the board. Next, we're going to pick the 5 volt power, and we're going to put that onto the 5 volt pin. This one's going to be for the 3 volt power, so this is on this side of the circuit board, so we're going to connect that up to there. And then here are our 2 control wires. So this will be switch number 1 and switch number 2. Okay, so that's all connected up now. And what I'm going to do now is I'm just going to click them. Okay, and hopefully you can see the little LEDs changing as they're coming on and off. I'm literally just turning those switches on and off from the Raspberry Pi. And you can hear the clicking going on at the same time, and that's these little relays clicking as we activate them. Now, as I said, you can power them from 3.3 volts. So if we put that pin back on, we do exactly the same again. You can still hear them, but they're just not quite as positive when that happens. So we put that back on there. This click should be slightly louder. And that's, as I say, because these really are 5-volt relays. So essentially now that could be wired up to something, and away it goes. I'll just show you the Node-RED config, which you've seen part of anyway, but we'll just build that out. But that's basically how we would digitally switch something using the Raspberry Pi. Right, so really, really simple. We're going to use the same sketch as we did before with the LED, except this time we want 2 of them. So we're literally just going to copy and paste this in underneath. We're going to have to give this some different names because we now want 2 switches rather than 1. So we would just duplicate that. We're going to have to change the pin because we don't want the same pin. So we'll pick a different pin. And it's still digital because we want that pin to either be on or off. We would just duplicate that. We pick a different pin. And these are obviously not relays, not LEDs now. These are relays. So relay 1. Or switch 1, whatever you want to call it, and relay 2. And then we would deploy that, and that's basically the config you just saw when I was clicking the switch button. It was literally just turning that on and off, sending a, you can see here this one's already got a 0, but it was sending a 0 and a 1. So I'll just scroll down a second so you can actually see some of the LED config. This is some of the LED config now, which we're going to go through, and we will actually build this out bit by bit. Because I'm doing that slightly different. So yeah, we'll come on to that in just a second. So here are the LEDs that I bought, and you probably saw these in the last video that we did when I was on the boat installing them, and I mentioned that they were USB powered, and this is the button that actually operates them and dims them. So my idea was to take that apart, have a look inside, and hopefully dim that, thinking that it was an actual button. Well, it isn't. So if I just move that out of the way for a second, here's the actual circuit board, and it's really quite clever, but also very complicated, and I can't quite work it out what it's doing. So it's got an LED driver from what I understand, and then it's also got some other circuitry to use and operate this touch sensitive button on the back, which I think is resistive, and I haven't figured out a way of actually controlling that with the Raspberry Pi just on the back, you know, using a wire, or I can't find the pins on here to try and operate it, and I just don't know how to do it. So if somebody knows how to do that, I'd be really interested, because I've Googled it and I can't really find out. So if somebody is watching it and going, yep, I know exactly what to do with that, drop us a message in the comments below and tell us how that we could do that, because I don't want to bin this, because it's quite a good little bit of circuit board. So what we're going to do instead. So the way that this LED works is it uses something called pulse width modulation. So in order to dim it, let me just plug it in. So in order to dim it, so it's on now, and to dim it like that, what it's actually doing is it's turning on and off very, very quickly, so fast that your eyes actually can't see it. Sometimes you see that as flicker through a camera, but to my eye, I can't see that flickering at the moment, and that's on about half power. So if I go up to full power, at that point now it's just on, so it's on constantly. And as I start to dim it, the periods of on and off time increase. So at the lowest end, at that end, which you probably can't see, let me just turn that light off. At that end, it's off more than it's on. And as we start to increase it, it's on more than it's off until it's completely on. So that's essentially how it works. So I've tried to do PWM with the Raspberry Pi. So I've bought myself another little bit of circuitry here, and this is an LED driver with PWM built in. And I'll connect that up in a second and I'll show you what happens. Okay, so just again, excuse the crudeness of the setup a little bit here, but what we've done now, so we've bought ourselves a LED driver with pulse, that uses pulse width modulation, PWM, to control the brightness of the LED. So this replaces this little tiny circuit board that we've just seen. It's exactly the same, LED, power in one side, LEDs out the other, power in one side, LEDs out the other. But now we've got 2 pins that we can take to another device, such as a Raspberry Pi, to control the brightness of these LEDs. If I just turn that on, you can now see that it's starting to come on, but you can probably see the flicker. Hopefully you can see the flicker. That's the problem. The Raspberry Pi, the way that the Raspberry Pi does PWM is it does it in software, so if the process is busy doing something else, you start to see flicker. You may also be getting some other flicker through the camera there, but I can see that with my eyes as well. So if I start to up the brightness, it gets a little bit better. A little bit of flicker again, but if I start doing some other tasks on the Raspberry Pi, then that flicker gets worse. And then at full power, there is no flicker. But what I can do for you is I can actually show you the pulse width in actual action with this. So if I just edit the pin that that's going to, and I drop this right down, you'll in a second see it going on and off. So you should be able to actually see that flickering now. So that's pulse width modulation actually in action, but it's doing it so slowly that we're actually seeing the lights going on and off. So I'll have to probably put a warning on there that that's flashing, but let's put that back up. And now it should be a lot better. So we can now control the LED brightness from the Raspberry Pi, but we need another bit of circuitry in the middle here. So that's what I'm just waiting for at the moment. So I'm going to show you this again in a second, but with another module in between here that will actually, that module will be doing the pulse width modulation, driving this, and then that should mean that the LED is really nice and smooth. So the question is, well, how much is all this costing? Well, not very much. These little modules here are only about £2 each. So I've got two of them here, so I can drive two sets of LEDs. So it's not an expensive solution. It's just taken a little while to actually build it up and make it work properly. And then I'll show you the control panel as well in just a second so that we can have a look at how we actually control them. So the next step will be to get rid of this flicker, and then we'll go through the config and the control panel. Okay, so now you'll notice there's another device in the mix. So this is actually, I think and hope, the finished setup. So we've now got this device that's appeared, and this works on the I2C bus. So we've got power to it. We've got SDA and SCL to this device, and then we're communicating with this. So then this device is sending out that pulse width modulation signal down to this driver, and that driver then is in turn turning on the lights, and we've now got a stable system. So if I turn them on now, I'll put them onto 25%. Hopefully there's no flicker. I can't see any flicker with my eye on them. They look perfect. So if I just turn this light off, it looks absolutely perfect to me. I can see a little bit on the screen actually. I'm just gonna let me just up something. Bear with me 2 seconds. Let's just change the sampling rate on it. We'll put it on 10,000. Let's see if that gets rid of it. Yeah, that looks better. Okay. So maybe we've just upped that enough now and the camera can't see it. I still can't tell the difference personally between those two. So just staring at the LEDs, they look exactly the same to me. But that's obviously got rid of it on the camera. But what's really nice now is, as I say, as I dim that right down, that's on 1, so that's on the lowest possible setting. It's quite dark in here, so it's picking that up quite well. On its lowest setting, there is no noticeable flicker, and it doesn't matter now what I do on the Raspberry Pi, that will not impact this, because we've sent the command to this unit. Let's put the light back on. We sent the command to this unit here, and this has gone, right, I'm going to send out that signal until you tell me otherwise, and that's what's going now across. So there's no impact on anything else. And obviously with this being I2C, you can put many of these together. You can add lots of different sensors and controllers and things on this boss without using lots of pins. So the pins are actually being used now on this side. So like the temperature and humidity sensor, that's also I2C that I've got on my boat. So you can stack these up essentially. I believe that's the finished article now. As I say, got full control over it. So what I'll do now is I'll show you the Node-RED config of how we've set that up, and then I'll draw this out in a little diagram. I'll put the components on there, I'll put the code online, and you can just download it and make it work. So the next steps for me are I'm going to connect the second one up so I can control both of them. I'm going to get 2 more of these, I think. So then I can drive 4 sets independently across this, so I can do 2 rows of LEDs on the top and 2 rows of LEDs on the bottom, And with the control panel, the LED control panel, I can mess about with the lighting levels on both sides, both up and down. But yeah, the other option is you can control things like servos with this. So you've got loads of different options with it, and you could maybe do something else with it. So it could come in handy in the future. Okay, so the Node-RED config that we had before is up there. So we're going to get rid of that because we don't actually need it. So we'll take that away. And this is essentially what we've set up. So it looks really quite complicated at first, but it's not. So I'll take you through a couple of things that you're going to need to get this up and running. So if you want to use the controller, that's this little node here, PCA 9685 out. So you have to download that first as like a library. So to do that, you go over to Manage Palettes, search in here for 9685, and you would see that pop up. So I've already installed that, and it was this one here that I installed. So in my nodes, that will appear. And there it is. So once that appears, you'll see down the left-hand side that appearing there. So you'll then drag that in. But just before we drag that in, you can also see that this is set to PWM. So when I was doing this previously, I was using just the standard Raspberry Pi GPIO out, setting a pin and setting it to PWM, and that's where I was running into the difficulty. So I've still got that in the configuration, so we'll take that out in just a second. So what is actually happening? So from the very start then, we've got that as the output. I've also configured a gauge. So on the left hand side here, I've dragged in a gauge because I want to see the level that we're sending out in the dashboard. So if I just jump across to another screen. So I'm just using a Node-RED dashboard here, and I'm calling that InKip. So it's just an embedded web page, that's all that is. We'll come back to how we've done that after, but this is what I wanted to see. So I wanted to see a gauge to say how much power we were putting out, a slider so I could move it, and then some options for predefined values. So on full, 50%, 25% off. And then this was the idea originally, using the relays to turn the things on and off. So if you watch the first part of the video, that's what you saw when I was clicking these things. That was turning the relays on and off. So I'm going to change that design moving forwards. But basically I've got a port and a starboard, so I've got it replicated for both sides. That's why I've got two of these. Port one, starboard one. So that's the gauge there, that's the output, that's the slider, and these are the values here. So if we just take a look at each one, so all this is just a button from the left hand side. So if we take a button, drop a button in, and we can configure it, and we can say what we want to do with that button once we touch it. So for me, if I open one of mine, the off one for example, this one is outputting 0. So the label is off and the output is 0. This sizing and this group, this is to do with the dashboard, but we'll come back to that. Next one, 25, so 25% power. Message output is 25%, 50 and full. So I wanted the word full, so the label is full, but the output is 100 to give me 100% power. So why do I then send that into the slider? Well, if you click it, it pushes the slider to the right place, and it also pushes the gauge. If I bypass the slider, so if I took that straight to the output, it wouldn't move the slider. So I want it to move the slider and to go to the output. So that's why those buttons go through the slider. In terms of slider config, it's 0 to 100 and it's in steps of 1. So what we want to be able to do with that is we want to be able to adjust this in steps. So if I want 26 or I want 9 or 10 that aren't one of these buttons, I have the option to do that. So I can go right down to 1 if I want to. And again, that gauge replicates what's being put out. So that's why that's set to that. And then what we're doing then is we're sending that to the gauge. So I've said to the gauge, it's a 0 to 100. I've done a color gradient on it. If you want to do a color gradient, that's what that's doing. And then I've given it a label. So I've labeled them port and starboard. And I've given them this grouping to go onto the dashboard, and also given it its size. So we don't actually need that anymore because that's replaced it. So that is basically what we've got. And then we're also, like we did with the switch, we're sending this output to SignalK so that we can tell SignalK what is actually going on and what the level is. So if I wanted to use that information somewhere else, then I can. For the switching bit, this is the switching config. So this is a little bit easier. So we've got an input, so that's listening for if we wanted to switch the switch another way. So if I used KIP with a button, that's the way that I could do that. But essentially what we've done here is exactly the same. We've taken from the left hand side a switch, we've dropped a switch in, and then on the switch config we've called it port low level. We're outputting 0 or 1 depending on what we want to do, and we're sending that to the pin, and we're also sending that as a topic and sending it out to SignalK so that we can see those values in the SignalK browser if we wanted to. So what we do need to do now is we need to copy that and paste that down here to do the port side one, and we need to delete that out. Sorry, the starboard side one, I should say. Connect the slider up. Now in here, that isn't going to be channel 0, it's going to be channel 1. And we'll deploy that. So that then would output to a second one for the second part of this. Let's just turn that off. So we could output 2 now. On startup, we've got a little bit of config here just to inject this once. And basically what that's doing is making sure it's off. So it sends off, goes through all this, but it creates this path. And that's the bit really I was interested in. So it actually creates those paths when it's turned on. So it goes through both of them. There's 2 different ones because there's 2 different things for when I was messing about with the relay. I can actually get rid of that now and rechange it back. But yeah, so on startup it's going through this and it's saying send out 0, away you go. So how do we create the dashboard? So if you click on dashboards here, you can see I've got this home and this LED panel. So if you click on the layout, you can actually see what it looks like. So port, starboard, they're the gauges, they're the sliders, they're the buttons, and these are the switches. Now, if you don't set, if you just go back into one of these, if you don't set this and you leave this on auto, they'll all be in a line. If you set these to a size that you want them, what you can then do is when you go to the layout page here, you can actually resize this stuff. So depending on how big you want this, so let's make that one really small, done, deploy, go back over to KIP, you can see it's gone really small. So let's put that back, sorry, layout. Let's resize that, full size, done, deploy, and it's back to the right size. So I wanted them side by side in KIP. You can see all the different things that it's included in because each one of those, the slider, the buttons and the gauge are all included in this. And I've also got some spaces in there as well just to make it look a little bit nicer, but you can mess about with that. And then what you need to do is you need to actually call that URL. So if we click this button here, it loads it in this page. So that is the actual Node-RED dashboard, the web page that it calls. So all you need to do is you need to copy that link. And then what you would do then is in your KIP configuration, if you were to unlock this, go into KIP, you can see I've just called the page that I wanted to use and to load that into there because I'm going to control it from KIP. Now, one of the questions could be, well, why didn't you use the button config that you used previously? So if you get the Boolean control panel up and you start adding some components, why are we not using that method? Well, you can't control the sliders. You don't have the option to go, well, I'd like this much power on. Or set these values. By incorporating the Node-RED dashboard, I can do that and I can basically set what I want. So that's the reason why I've moved away from doing the switch panel and I've embedded this page now in KIP to control it. So that's one of them and this is the other one. So they're exactly the same. There's no difference between them and it's basically just using a series of buttons, a slider, a gauge, an output, and just sending the value through it. It's really, really not that complicated. But as I say, what I'll do is I will copy this code and I will put it online. And if you want to look at that, how that's set up, you can just download it and you can import it. And if you want to do that, you go to the little menu here, you press import and you just paste the code in there. So you'll find the code on the Boating with the Baileys GitHub page. So you can just copy it and paste it in there. What we'll do now is we'll have a quick look at the circuit diagram and then that concludes the video. Okay, so the very last piece of this is just looking at the circuit diagram. So we've got this new board, this PCA 9685 device, and as I say, that is connected to the Raspberry Pi. So if we just get a pencil, So the ground pin to the ground pin on the Raspberry Pi. Then we would have the power pin, which is this one here. That would go to power, so to 3 volts. SCL to SCL, SDA to SDA, and then the very first PWM pin on here, I don't think I can draw onto that one, would come down to PWM here. So this needs joining to this, and ground needs to be joined to ground as well. So we need to connect that to the ground pin here. Once that's connected up, these 2 pins here, this one is to the positive pin on the battery. This is to the ground pin on the battery, and these are your LED outputs here. So the negative side of the LED and the positive side of the LED on there, and that essentially powers the whole kit. That's all you need to do. This little driver seems to be absolutely fine up to 36 volts. So that's then regulating the power down to drive the LEDs, absolutely fine, and then it's being controlled with the PWM from the chip above. And that's basically it. I hope this video has been useful. It's been a little bit longer than some of the other ones, but yeah, hopefully covered a lot there. And if you've got any comments, any suggestions, anything that we can do better, then please let us know. Please put a comment. Please give it a like if it's helpful. Maybe we'll look at some ESPs and smart switching as kind of like a remote setup. So if that's of interest, again, come back to us, give us some feedback, tell us to do that, and we'll see you next time.